Hi everyone, I'm Yogeshwari from CMR Institute of Technology. I'm here to demonstrate the microwave oven simulation which is done during internship at Emotex. Firstly, let us take a look at contents which I have learned during internship. The topics included are C programming, embedded C, microcontroller versus microprocessor, what is embedded systems, project requirements, microwave oven and implementation. Further proceeding, C programming. C programming is a general purpose programming language. It can be used to develop software like operating system, databases, compilers, and so on. Embedded C. Embedded C is an extension of C language and it is used to develop microcontroller based application. Embedded C is fully hardware dependent language. Embedded C is OS dependent. So the number systems included in embedded C are as follows: decimal, which has a base 10 and includes the digits from 0 to 9; octal, which has a base 8 and includes the digits from 0 to 7; and then hexadecimal, which has base 16 and includes the digits from 0 to 9; and then alphabets from A to F; binary, which has a base 2 and includes the digits 0 or 1. Then coming to data representation, embedded C has three types of data representation as followed: bit, byte and word. Bit, it is the states. In this, states are coded as 0 or 1, called binary digits. It is basic unit of information. Byte, it consists of 8 bits. It is considered as smallest addressable unit of memory. Word, amount of data a machine can fetch and process at one time. So the integrated number can be represented in two ways in embedded C, either as positive or negative. Negative number is represented by 1's complement of a positive number. Data types included in embedded C are as follows: integer and floating point. In floating point we have two different sub, again called as float and double, and in integer we have two different sub called as char and int. Coming to conditional constructs, we have two different types: single iteration and multi iteration purpose. For single iteration purpose, we generally use if else, or if else if, nested if and switch case. If statement is to specify a block of code to be executed if a condition is true. Switch allows us to execute one block of code among many alternatives. For coming to multi iteration, we have for loop or while loop and do while loop. For lets us repeat a statement for a specified number of time. While will helps us repeatedly execute a target statement as long as given condition is true. While loop is generally called as entry control loop, whereas do while loop is called as exit control loop. And then moving forward to jumping statements, we have three different jumping statements available in embedded C as shown: continue, break and go to. Continue, a continue statement causes a jump to the loop continuation portion, that is to the end of loop body. The execution of code appearing after the continue will be skipped. Then coming to break, break is used to exit the loop. And the operators that we have in embedded C are as follows: arithmetic operators, logic operators, relational operators, bitwise operators and assignment operators. So generally operators are used to operate on the operands and return a specific value after the performation of the operation. So arithmetic operators include like plus, minus, asterisk symbol, and then division symbol called slash, and modulus symbol. Whereas logical operators examples are like and or. And relational operators includes greater than, less than or equals to and not equals to. Bitwise operators include not equals to, and then power symbol, left shift, right shift and all. And coming to assignment operators, which is specified by using plus and equals to symbol. And some of the basic things we need to know here, and which we come across in embedded systems, are like arrays, pointers, functions, strings and storage class and preprocessors. What is arrays? Arrays is a collection of data of some data types addresses a sequential manner. Pointer, a variable that holds the memory address. Functions, a function is a block of code which only runs when it is called. You can pass data known as parameters into function. Strings, sequence of characters terminated with a null character. Storage classes. This storage class is used to declare static variables which are popularly used while writing programs in C. Preprocessor, a macroprocessor that is used automatically by the compiler to transform your program before actual compilation. So now coming to the difference between microcontroller versus microprocessor. So what is microprocessor and microcontroller? If we look into it, microprocessor is a processor where the memory and IO component are connected externally, whereas coming to microcontroller is a controlling device wherein the memory and input output component are present internally. Coming to the circuit complexity of these two, the circuit is complex due to external connection, whereas in microcontroller, the circuit complexity are present on chip memory, the circuit is less complex. What is embedded system? An embedded system is a combination of computer hardware and software designed for specific function. Embedded systems may also function within larger system. The systems can be programmable or have a fixed functionality. Unlike general purpose computers, which are versatile and can run a wide range of software applications, embedded systems are tailored for specific purposes and typically optimized for efficiency and reliability and real time operation. Categories: standalone, real time, and network mobile are the different categories available. Standalone, slave and independent are the two different categories, subcategories in standalone. Real time reacts according to the time airbag. Example is the airbag. Networked, wireless systems are connected over the network. Example, ATM machine, routers, and home security system. Coming to mobile, embedded systems are movable. Example, car. Hybrid embedded system, which falls under different categories. Example, robot. Some of the real-time aspects of embedded system are: hard real-time, should meet its deadline, which means it should meet its deadline. Life critical, these are life critical, and applications are such as airbag system and ventilator. Firm real-time, which is similar to hard real-time and has a similar properties. Soft real-time can have tolerance in meeting its deadline. Example, soft real time can be even our normal embedded systems which we use in our daily lives. So now components of embedded systems are mainly microcontroller, microprocessor, memory, input output interfaces, sensors, and actuators, etc. So now my friend will continue the topic and she'll be explaining about the project.
Okay, I'm Sahiti and I'm going to explain the project requirements and the simulation part. So, the project requirements are in this we have hardware and some software also. We have in hardware we used microcontroller. The microcontroller which we used is PIC16F877A, and we used LEDs, LCD display, keypad, tactile switches, timers, buzzers, and fan. The software which we use it for the simulation is MPLAB XID, XE8 compiler, and PiximLab. Now coming to the PiximLab architecture, it is a 40-pin microcontroller designed using RISC architecture, manufactured by Microchip, and is used in embedded projects. It has 5 ports on it, starting from port A to port E. It has 3 timers in it, 2 of which are 8-bit timers, while one is 16-bit. Coming to the LED, LED is a semiconductor device used in many electronic devices, mostly used for indication purpose. It is used widely as indicator during tests for checking the validity of results at different stages. It works just like diode and it consumes low energy, it has longer life and small size. Then LCD display. It is an display can be used as an output device to display real-time information or results of the system's processing. The embedded system solution controls the display by sending the appropriate signals to the LCD controller, which in turn updates the display. In this, we have D0 to D7 data lines and one RS line, that is resistor select. When resistor select is 0, it will take as instruction, and when RS is 1, it will take as data. We have two types in it, that is 16 cross 2 and 16 cross 4 LCD. We are going to use 16 cross 4 LCD in this. Then data processed by two methods, that is delay method and pole D7 method. Then coming to the matrix keypad, It consists of a push button switch that are located at the column and row intersection of a grid or matrix. Switches in the same row are connected together as or switches in the same column. This uses rows and columns concept we use commonly in telephonic calculators, digital lockers, and many more. Tactile switches. A tactile switch is one type of widely used switch that completes an electrical circuit typically when pressure is applied to the device by the user. In this, we have level triggering and edge triggering methods. Then there are two interfaces on this. There are pull-up resistor and pull-down resistor. In pull-up resistor, when switch is open, microcontroller pin will be 1, and when switch is closed, microcontroller pin will be 0. In pull-down resistor, when switch is open, microcontroller pin will be 0, and when it is closed, it will be 1. Coming to the timers, a timer is a specialized type of clock used for measuring specific time intervals. It has 3 modes in it, like PWM, counter, PW or PP measurement, etc. Here we have some parameters on timers. They are tick, quantum, scaling, and resolution. Tick is nothing but the up count or down count, and quantum is system clock settings. Scaling is we have pre or post scaling. Resolution is the resistor width. Then coming to the microwave oven, how it works. And a microwave oven is a relatively small box like oven that raises the temperature of food by subjecting it to a high frequency electromagnetic field. Microwave ovens are used to reheat and cook food, distinct kitchen items, make citrus fruits juicer, heat beauty products, roast garlic. Here we have 3 modes in this: microwave mode, convection mode, and grill mode. In microwave mode, when you simply want to cook something like rice, Maggi, etc., we use microwave mode. In convection mode, it is used for baking cakes or cookies. In grill mode, it is simply used for grilling. So coming to the project, first when you open the microwave oven, the power on screen will be opened and it will be displayed as powering on microwave oven. Next, the cooking modes will be displayed as grill mode, microwave mode, convection mode, and start. Coming to the micro mode, power will be displayed as 900 watts, and then we'll be getting time display screen, and here we should enter the time by keys. Hash is used to enter the time and star will be used to clear the time. In micro mode, the time will be started and user will be having options like start or resume, pause, and stop. Coming to the grill mode, when users presses 2, it will select grill mode and the procedure is same as that of micro mode. The timer will be running, and again if the user presses 6, that will be stopped and goes to the mode screen. Coming to the convection mode, when we press 3, the convection mode is selected and the user should enter temperature below 250 degrees Celsius. And when you enter the temperature, the timer will be set for 180 seconds by default and it will be preheated. After preheating screen is displayed, we'll be having the time display screen and you should enter the time for heating. Then we'll be getting the same timer display which will be running and the timer will be decreasing. Let us see the demonstration. Okay, when you start the microwave oven, we'll be seeing the powering on screen and then we'll be getting the modes here, like micro mode, grill mode, convection mode, and start mode. When you press 1, we'll be getting the micro mode. And the power will be displayed as 900 watts. And here we will be getting set time display, and here you should enter the time. Let me give 23 seconds and 1 minute. And if you give hash, it will be timer will be started and timer gets reduced. Here we'll be having 3 options like start or resume, pause and stop. You can use any option as per your requirements. So I'm using stop to go back to the modes. And now when you press 2, we'll be going for convection. When you press 2, we'll be going for grill mode, and same set time display will be there, and we should enter the time, and let me take us 30 seconds. And if you want to clear it, you can use star, or again, if I enter the time as 30 seconds, press hash, so the timer resumes again and the time will be reduced. You can pause by using 5th, and if you want to resume, you can press 4. For stop, you can use 6. Then coming to convection mode, we have to set the temperature at first. So I'm taking temperature as 123 degrees Celsius, and if you want to clear it, you can use star, and again let me enter the temperature 123 degrees and give enter. So the preheating time will be taken. By default we gave it as 18 seconds and it will be reduced. After the preheating is done, we have to give the time. So let me give it as 23 seconds and enter. Again stop it, and for the start mode press 4. Same time will be displayed, and by default it will be 30 seconds, and when you start or resume again, the 30 seconds will be incremented in the time. You can see that. And if you want to pause, you can use 5, and if you want to stop, press 6. So this is the microwave simulation in PicSimLab. Thank you.